I think today is the easiest day of the whole year. What?
Is it recording?
Yeah,
What did I do?
yeah, so I think today's the easiest day of the whole year. It's going to be really quick. We're going to fly through it, and then we're going to check our test, and hopefully give you a chance to reassess today if you'd like. If you have the opportunity to. And we'll talk more about how you reassess and things like that again at the end of class when we get there. All right? All right, so second unit, matrices. Adding, subtracting, and scalar multiplication today. Like I said, I think it's the easiest day of the year. Should go really quickly. Matrix operations. Oh, that's supposed to be up. Vocab, first and foremost. A matrix. What is a matrix? Well, it's a rectangular arrangement of numbers in rows and columns. The plural of matrix is matrices. No, nothing.
Haha.
Well, thinking. I thought there should be an announcement.
Oh, I thought it was supposed to be a joke or something.
No. Alright, so rectangular arrangement of numbers in rows and columns. That rows and columns thing is really important because when we go and we talk about how we describe matrices, we describe them using their rows and columns. So dimensions, like I just stated. How we describe a matrix is by its dimensions. The number of rows by the number of columns. So number of rows is always listed first. Which way do rows go?
Right to left.
Right to left, left to right. Columns go up and down. So we describe them rows by columns. Like I said, keep in mind rows are inside side, columns up and down. So example, a 2x4 matrix would have 2 rows and 4 columns. So if you look at the one up here, 2 rows, 4 columns. We would call that a 2x4 matrix. Pretty simple, right?
Sure.
Sure. So a 2x3 matrix would have 2 rows, 3 columns, right? The other thing we want to talk about is corresponding location. Well, and a zero matrix there. So corresponding location means it's in the same row and same column location in 2 different matrices. And that'll come into handy when we start doing adding matrices here in a second. When we talk about multiplying matrices later on in the unit. Well, that reminds me. By the way, if you don't have a graphing calculator yet, you're probably going to need one tomorrow when we start multiplying matrices, unless you want to do them all by hand.
Yeah.
And that would really suck. Now, today it's really not super important that you have a graphing calculator, but tomorrow is pretty important. So, corresponding location, the same row and column location in 2 different matrices. And last vocab word for right now, for like the next 2 seconds, is a zero matrix. A zero matrix means that all the entries in the matrix are 0. So it could be like a 3x3 matrix, could be a 26x26 matrix, could be a 6x4 matrix, but every single entry in it is a 0. That's why I call it a zero matrix. Alright? Cool?
Yes.
Sweet. Am I good to move on or are we still writing?
You're good to move on.
Alright, so what is the purpose of a matrix? A lot of movies, video games, a lot of graphic stuff actually has matrices in it, in the background, dealing with the computer animation. Wow, words are really hard. Computer animation, we don't see it, it's a lot of behind the scenes things. And actually, when we do solving systems next quarter, I think it's the 8th unit of the year, we're actually going to use matrices to solve some of our systems. We get like 3 variable systems, 4 variable systems. We're actually going to use matrices to solve them. So you do need to remember what we're doing this unit for the end of the semester.
Uh-oh.
Yeah, uh-oh. We're going to skip the roll application because I don't want to do it. So, matrices are considered equal if they have the same dimensions and each corresponding cell is equal. So they are considered equal if they have the same dimensions. It's the first thing you should check for, same dimensions. And each corresponding cell is equal. So if we look at these 2 matrices up here, first and foremost, do they have the same dimensions? I should wait. I'll give you guys a second to write it down. I'll give you a second.
Appreciate it.
Alright, do we have the same dimensions?
Yes.
Yeah, right? We have a 2 by 2 matrix and another 2 by 2 matrix. Alright, so we're going to see if they're equal or not. for them to be equal, their corresponding cells or corresponding locations need to all be equal. What that means is, does 2.5 equal 5/2? Yeah. Does -1 equal -1? Yeah. Does -0.2 equal -1.5 or 1/5?
Sure.
Yeah. And does 0.33 repeated equal 1/3?
Yes.
Yeah. So they all are equal, they have the same dimensions, then the two matrices are also equal. Alright? So if we look at the second one, are those two equal? Are these two equal right here?
Yes.
You can't say no and yes.
I just said.
How many people think that they are equal?
Oh.
How many people think that they are not equal? How many people did not vote? How many people still haven't raised their hand? What do we think? Who said yes? Anyone? Who said no? Why do you think no?
Because 1/6 does not equal 0.3.
1/6 does not equal 0.3. Exactly, right? They have the same dimensions. 3 of the corresponding cells are correct. But that 1 is not correct. So they are not equal. Those two matrices are not the same. Alright, does that make sense? What makes them equal? Alright, sweet. Then we're going to talk about adding and subtracting matrices. So adding and subtracting matrices. That's a lot right at one time. So, this can only be done when they have the same dimensions. So just like when they were equal, they had to have the same dimensions. If we're going to add and subtract them, they're going to have the same dimensions. So they must have the same dimensions, and the sum or difference will have the same dimensions as the original matrices. So that means our answer matrix, we're going to have 2 matrices we're adding, or maybe even 3 matrices at some points. When we add them together, they should have the same dimension as our original matrices. And if the dimensions do match, we can add or subtract the numbers that occupy the same positions in the matrices, or that are in the corresponding cells. So if they match, we're going to add or subtract the numbers in the corresponding cells. So we'll do 3 of them together, and I think there's 3 for you guys to try. So our first one, first and foremost, I want to add those together. I need to check, do they have the same dimensions? Same dimensions?
Yes.
Yeah, what are they? They're both what type of matrices? 3 by 1, right? 3 rows, 1 column. So to add them, add the corresponding cells. 0 plus 1 is 1. 4 plus -9 is -5. 3 plus 8 is 11. And that's my answer. Now, when you write your matrix, you write your answer here. Don't just write 1, -5, 11 on your paper. Put brackets around it. That makes it a matrix. If you write just 1, -5, 11, it's going to get marked wrong. It needs to look like a matrix. Second example. Can I add those?
No,
Why not?
they're not equal for the numbers, or for the dimensions.
The dimensions are not equal, right? This one's a 1 by 2, this one's a 1 by 3. So we can't add them. So can't add. But don't just tell me you can't add. I assume you can add, you're in here, right? Tell me why you can't add them, please. Can't add different dimensions. Tell me, what's wrong with them? Why can't you add them? Like I said, otherwise I'm going to think that you just can't add in general. And I know that's not true. Alright, our last one here. I have a 3 by 1 and a 3 by 1. 0 minus 1 will give me -1. 4 minus -9 is 13. 3 minus 8 is -5. Add or subtract those corresponding cells. Alright, any questions on those 3? There's 3 more right there for you to do, please. And hopefully we can get some volunteers up to the board, otherwise we'll have to pick random names. Anyone want to put one on the board?
Pick somebody.
What?
Pick somebody.
Do you want? Whichever one you want to do. 1, 2, or 3. Whichever one. Which one are you gonna do?
I'll
You
do
do the
two.
first one?
I'll do two.
Does anyone want to do number 2? You gonna do number 2?
Yes.
You do number 3?
No.
No?
Yeah.
Someone want to do number 3?
I'll do three.
Who wants to do number 3? Because apparently Jared doesn't want to.
Jared,
You do it? Alright.
Really subtract.
I know. I just wanted the right can't add. You got it, Jared. I believe in you.
I remember my number.
Is that a dot? There you go.
Oops.
Can't add IU for instance.
What?
But
So you don't have to like.
yeah. Can't even see the board. It's the white screen. I'm shaking your hand.
Alright. Do we agree with them?
Yes.
Do we agree with those 3?
Yes.
Yes, no? We all got those answers? Do you have any questions on it?
No.
So we can keep going?
Yep.
Sure.
Alright. Scalar multiplication. So, multiplying by a scalar. What that means is we're multiplying by a real number. Now, a lot of times in this unit, we'll use whole numbers. I think there's a couple times where we give you fractions or decimals to multiply by. What that's going to happen is we're just going to multiply every entry in the matrix by the scalar. I like to think of it as you're distributing a number through parentheses, right? You have like 2 parentheses and you have some sort of expression in there. You distribute that 2 all the way through. Same thing with the scalar. You're going to take this 6, and we're going to distribute it to all the pieces in that matrix. So I'm going to go 6 times 2 is 12. 6 times negative 3 is negative 18. 6 times 8 is 48. 6 times 4 is 24. I'm just distributing it to all those pieces. No, you do not need to draw those lines when you do it. Just helps to visualize it sometimes. So go ahead and try that next one, please. There's another one there for you.
It's pretty cool.
I've been amused by it for a while today. I figured it out.
Did you just figure it out today?
So I've been playing with it a little bit.
How did you figure it out?
I went to slide it and I just tapped it and it changed.
It's always been the boring gray color.
So you want it to be gray, is what you're saying?
No.
I
Do
like,
the
like the
yellow.
pink.
I
Yellow.
like the boring
Yellow.
blue.
Yellow.
Oh, yeah.
No.
Alright.
Oh, I like that one.
No.
No. There. No.
Oh.
That one?
No.
No.
That one's not
That
even
one's
right.
not
The blue one.
Do
No, not that
Oh,
one.
let-
the, keep going. Right after the gray, the blue one.
That.
Yeah.
Yeah.
That one?
Yeah.
Yeah.
Yellow. Yeah, keep it at
There we go.
yellow.
Alright, there we go. Alright, does anyone want to put it up there?
It's an ugly color.
Just never gonna raise my hand.
No?
Nope.
Never gonna win. Get out of here. Oh, get all the time in the world.
Yay.
Thank you. Means we can do more problems, cool.
Yay.
One more problem to be specific. Alright, do we all agree with that? Negative 21, negative 12, 0, 15?
Yes.
Any questions?
No.
Alright, how would you do this one then?
Probably
This one just disappeared.
just distribute the 3 to the first one.
Probably distribute the 3 first and then,
I know.
now what do you call that? We multiplied and then we added.
Distributive multiplication and add and subtraction.
What they're saying.
No, something way more simple. Something you've done probably since 7th grade.
Factor. No.
Starts with an O.
Operation.
E-
Operation.
Order of operations.
Order of operations, right? Same thing applies with matrices. You have to multiply before you add. Alright, so we're going to multiply, do our scalar multiplication first, and then we're going to add them. Order of operation still matters. Alright, so do your scalar multiplication, we should get -6, 33, 9, 3. And then we can add our other matrix. Now, these ones work out nicely, we get the same dimensions, so we can add them. Other ones may not. Alright, -6 plus 4 is -2. 33 plus 10 is 43. 9 plus -8 is 1. 3 plus 5 is 8. Alright? Does that make sense? Any questions? We're done. That's it.
No more recording?
No more recording.
Yeah.
Say bye.